Okay, so we're going to do one more example of solving exponential and logarithmic equations. And for this last one, I picked something that's a little more interesting because it uses a few different techniques than you've probably seen in the past. You've seen them, just probably not put together in this particular configuration. So here's the equation I want to solve. E to the x minus 2 equals negative e to the negative x. And the first thing we should see here is that I've got a negative here. I just can't take the logarithm of both sides because we know negative numbers are not in the domain of logarithmic functions. So I'm going to move everything over to the left, and I'll have e to the x minus 2 plus e to the negative x is equal to 0. Now I've got my e's all positive, these pieces that have my variable exponents in them, but the problem is, again, I just can't take the log of both sides because I don't know what to do with the log of a sum. So what I'm going to do is I'm going to rewrite this one more time so that we can see a little bit of symmetry here. And really, okay, with this negative exponent, what I'm dealing with is a fraction. Okay, well, if I'm just dealing with a fraction, then I know one way I can deal with this in solving equations is to multiply everything by e to the x. So that's what I'm going to do. If I multiply everything by e to the x, then I get e to the x squared minus 2 e to the x plus 1. And if I let u be equal to e to the x, I can see where that transforms this equation into something that looks like u squared minus 2u plus 1 equals 0. Well, this is just a perfect square quadratic trinomial. Not a big deal. We know how to factor these, right? We remember factoring. So I'm going to rewrite that as e to the x minus 1 quantity squared equals 0. And now I can use our favorite technique for this, the principle of zero products, and say, in order for this to be equal to 0, the sum inside here has to be equal to 0. So I will have e to the x minus 1 equals 0. So e to the x is equal to 1. Now I've got two ways of looking at this. First, I can say, okay, if it's going to equal to 1 and it is an exponential, then really what I need this exponent to be is 0. So I know e to the 0 is equal to 1, so x has to be equal to 0. Or we can go ahead and take the natural log of both sides. We want to use what we've learned in our principles of logarithms. And so I know the logarithm of 1 is 0. I know I can rewrite this left side as x times the natural log of e. And I remember from my intro to logarithms, from all my properties, that the natural log of e is just going to be 1. So I have x times 1, and that gives me, again, x equals 0. So again, I thought this was a little more interesting, the sorts of things you will run into as you continue on in mathematics, where we start to see ideas combined. And sometimes they're not always obvious. This e to the negative x could throw some folks off from the early stages. So that's where sometimes if we rewrite it as the fraction that it wants to be, then we can see where some of our other techniques will come into play to clear the fractions and see what we're ending up with there. This really comes with the mathematical problem-solving idea of get your hands dirty. So don't just stare at it and, throw your hands up after 30 seconds and say, I don't get it, I don't understand it. This is an algebra class, so get your hands dirty, start playing with it algebraically and see where you come out at, because there are some other patterns that might pop up that you can see that will help you solve it. So, I hope that helps. Don't forget, please be checking out those examples on Patrick JMT and Math is Power for You, because there's also lots of good examples and hints and techniques on those as well. So, good luck and keep in touch.